Hello everyone, here's a helper file for assignment number 3 in LIS3781 Advanced Databases. Gang, you've used a case tool for database design in the last two courses that you've taken in our database sequence, LIS2780 and LIS3784. In LIS3781, I want to make sure that you're getting sufficient experience with strict SQL. So with this video, I hope to have you accomplish that, getting more basic understanding of SQL and be able to write that in case it's needed without depending upon a case tool. Let's begin. First of all, I'd like you to save this file as LIS3781 _A3 solutions.sql. You should be able to see that. If not, you could enlarge the display there so you can see that. I'm going to try to keep it at this resolution right here. I don't want to go too much larger because then I'm going to get into horizontal shifting, and then you won't be able to see some of the code to the right of the window. So with that said, again, please save this file here, as you may or may not be able to tell in the lower left corner here where my cursor is. That file is saved as LIS3781 _A3 solutions.sql. And I saved this file in my LIS3781 directory as well. Alright, a couple things. We're in this, if you haven't had any experience with the T command and some Unix commands, we're going to be doing that in this course as well too. I know in other courses I've had you do Unix commands. This command is called the T command, and what it will do is it will essentially help you with documenting your SQL statements and provide for you an external documented file. So here's some comments here that you could review. I also will actually execute this T command later on in the code below. But this is the, you don't have to write this down right now. I'll have documentation later on that you'll be able to see. I provide the documentation for both Windows and Mac users, as well as if you wanted to do this on the CCI server. Essentially what a T command does is just it reads standard input, and then it writes the input to not only the standard output, but also to other files if you wanted to. Essentially what it does is it's duplicating or replicating the input that is going into what we call the standard input, which what we're going to be using is either terminal on a Mac or the command prompt on a PC. And then at the very end, what you would do is you would T command, give it a path, and then at the very end you would say no T, and it's just one word, NOTEE. And I'll show that again later on. Okay, so what you're going to be doing here is creating your FSU ID, that is your database. Please do that locally and remotely like we've been doing in the last two courses. Here locally, you would just create your FSU ID, and that way everything will port over nicely to your remote database on the CCI server. You can read the comments below, and you're also going to be sure to review the following documents in the notes area of Blackboard. And here, and if we're not on Blackboard anymore, if we're on a different LMS, a different learning management system, I'll have that in a similar notes area. And these are the files that you'll be reviewing for this assignment. Enforcing primary key foreign key relationships, an intro to views, an intro to store procedures, an intro to triggers, and finally an intro to transactions. And then what you want to do is make sure you go to the class site that I have for you. If you look at the notes section, go to database resources, and under database resources are some MySQL tips. I've talked about this before, and I'm not going to talk about it again. You can do research on your own. And there's a link right there, a URL for you. And this is essentially explaining what collation is and what a character set is. If you want, you could do further research on your own. You want to post some notes or questions to the discussion board. Comments would be appreciated. Any questions, I'll be happy to answer those questions that you post. But please do the research first as far as what character sets are, why we use character sets, and what collation is. You'll see that generally what I do is have you use UTF-8 for a global marketplace, so that most characters will be available inside of MySQL or any other database management system if you use UTF-8. By the way, that's not just for databases, it's also for web applications and other, if you're doing any type of programming, you want to make sure you're making it compatible with other languages. UTF-8 would be basically the most compatible with all languages in a global marketplace. All right, let's begin with the code. First thing what you want to do, and I may not go in here and explain some of these comments, but you can read them as you go through this video here. I have those comments there for your internal document, not only your internal documentation, for mine as well too. I usually put comments in my code, and then a lot of times in the videos that I provide, I put extra comments so that you can understand what's being, why the code is used the way it is. First thing you want to do, lines 45 through 47, is drop your database if it exists, create the database, and really you can duplicate that. Now it would be redundant. But you could do this as well, and that is create database if not exists. Okay, so drop database if exists, and that way you would only get a warning rather than an error. And then finally, don't forget, gang, you want to make sure you use your database name. Again, please don't try to drop my database. You want to make sure it's your FSU ID. Okay, so please drop database if exists, your FSU ID. Create database if not exists, your FSU ID. Use your database. Here I'm just showing you with mine. Okay. Now this is important about turning foreign key checking off. I first want to say why we're doing it. The reason why we're doing it is because what you would normally have to do when you create your databases is create the parent tables first and then the child tables. How can you have, when you're forward engineering your data, how can you actually have data for foreign keys in your child tables if those parent tables aren't created? If you tried to create your child tables before the before the parent tables, you would get an error. So if you had 50 tables, you would have to put all of the parent tables first and order them, and then put the child tables next. Not only that, even if you did that and there were tables that had multi-relationships, like dual relationships with each other, right? Say one table had a one-to-many relationship with another table, and those two tables had a converse relationship, where say table A had a one-to-many relationship with table B, then table B had a one-to-one relationship with table A, and the foreign key of table B was the primary key in table A, you would have this relationship that could not be forward engineered. So what we would do is turn foreign key checking off, and this is how you do it. By the way, this is a what we call a session variable here. If you're going to use a global variable, you would have to use a global keyword. Here we would just this would be, excuse me, this is implied there. So that's a session variable. Without the session keyword, it's implied that it's a session variable. Be careful, gang. There are no spaces between foreign and key and checks. There's an underscore between foreign, key, and checks. And what you're doing is you're turning foreign key checking off. After you create the tables, after you create the inserts, then what you want to do is, after all of that, is turn foreign key checking back on again. Make sure you do that. Do not forget to turn the foreign key checking back on. Okay? All right, let's go back here. So essentially what we're doing here is we're creating 4 tables. As you'll see in your assignment 1 requirements, you're going to be creating 4 tables. for a fictitious dealership database design. And the first table, actually the overarching table, what we call perhaps as an appropriate name would be called the super table, is dealership. And it just so happens that customer is a child table. And you'll see later on when I show you how to backward engineer this design, you'll see exactly how this is put together. So customer is actually a child table, and if we didn't turn foreign key checks off, we'd get an error if we tried to populate this customer table, because essentially the parent table would have to be populated first. And by the way, before the dealership table, it's actually a child table of sales rep. So customer is a child table of sales rep, which is a child table of dealership, as you'll see when I show you the ERD. Okay, some code here. I'm going to try to show the tables in their entirety, and unfortunately I cannot here. So I'm going to break this down. Here is let me put a space here. Here is the table structure for the customer table. Now, you could see the comments there. You can see the attributes. And I'm going to try to go kind of quickly, because all you have to do is pause it. Here are indexes, and you'll see that below that are the foreign keys. Now, there are a couple of ways to show foreign keys, because one of the exercises for assignment 3 is to be able to show the foreign keys. Now, here are your indexes, okay, and what we're doing is we're indexing our foreign keys here. Plus, we're indexing last name and social security number. Now, why we're doing that is the foreign key actually is sales rep ID. So we're creating an index for the foreign key. We're creating an index for social security number in case it's going to be searched at the dealership. And we're also indexing the customer last name in case someone calls up and the customer rep has to search by social security number or last name. So we want to make sure we index those attributes. And of course, you always want to make sure you index the foreign key. How can you show the foreign key? You can show the foreign key like this. Show create table customer. You could do that. I have a comment here that if you don't use a constraint keyword here, lower on, it will actually show you an alphanumeric value. So this constraint keyword is really giving a name to this foreign key. Now, I may not have time to demonstrate this. I'll try to demonstrate it in class instead. But just realize that the constraint keyword is saying whatever follows it is the name of this foreign key. Okay? All right. So the indexes are prefixed by IDX, followed by the attribute name. So I'm saying IDX underscore SRP underscore ID, and here I'm indexing these attributes. As I mentioned, if I wanted to show the foreign key, I could do this. Show create table customer, and that would just essentially show me the entire creation of the customer table. There's another way to do it too, and that is we haven't used it, but we can use it. Let me make this a little bit larger so you can see the code here. And that is the information underscore schema table. And that underscore information underscore schema table would allow us to see our foreign keys. So the code for that would be just like this. Select fkey dot table underscore schema as schema, fk dot table underscore name as table. Don't forget your commas there. Fk dot column underscore name as column. Fk dot constraint underscore name as constraint name. From information underscore schema dot, and that is what we're using here is the database name is information underscore schema, and then we're using the table. We're fully qualifying this, by the way. The database name is information underscore schema dot table name, and that table name is column key underscore column underscore usage. And then we're just saying that we're going to give this an alias of fk. And then finally a where clause, where fk.reference underscore column underscore name is not null, and fk.table underscore schema like mjoet. In other words, it's saying like the database mjoet. Now all you would do is supplant my database name for your FSU ID to make this work. And all this code would in fact work. And that's one way to show the foreign keys. Okay? Alright, let me get out of here, put that back. Okay, and so that's the customer table up to the indexes. And now what we're going to show, I showed you how to do the foreign keys, and we're going to show the remaining table definition of customer. Here's the foreign key, is going to be sales rep. All of the foreign keys will be on, delete, restrict, on, update, cascade. Here's how you would explicitly define the engine. By the way, by default, it's InnoDB. It used to be myISM, but now it's InnoDB. How you change the character set, and then with the collation is going to be UTF-8 underscore general underscore CI, stands for case insensitive. Show warnings is so that if there's any warnings here, like there would be, by the way, there would be, if in fact we include this statement right here, drop database if exists mjoet, we're going to see a warning with some of these commands here. But a warning is better than an error, and that's why we do if exists. So drop table if exists. We don't need, once we do that, we don't need create table if not exists, because we're dropping the table. It's the same thing that we would do here with database. Once we drop that table, we don't really need create database if not exists mjoet. All we would need to do here is just put create database your FSU ID. Okay, but I just did that just to show you how you could do that on a create statement. But the bottom line is, using if exists and if not exists will give you a warning if they do exist or if they do not exist, versus an error. So that would give you a warning and not stop the application processing. All right, here's some data for the customer table. Now you don't have to use my data. Okay, you don't have to use my data. Notice how after every create statement, I have show warnings, and after all the insert statements, I have show warnings. All right. Notice how my code, I'm using my Emacs, as you know, my favorite text editor. Notice how it's not showing a differentiation with the keywords. And the problem is this, and your text editor may do the same thing. Notice how this line right here is different from these four lines. And it's because of two characters. Notice how I'm trying to do an apostrophe, not a single quotation mark, but an apostrophe. And so, because I have to escape that using a backslash, if I didn't do that, it would treat this as a single quotation mark. And I don't want that as a single quotation mark. I want it as a backslash. But the problem is it's messing up the rest of my code here. Now, I still have to use that if I want it as an apostrophe, but just so that I can make the code a little bit easier for you to see, I'm going to take this off. Notice how everything cleared up when I did that? Let me show you that again. It's because of that single apostrophe. Emacs is intelligent enough to see that as the beginning of a string, and your text editor may do the same thing, but I'm going to just take that out here right now, and just so that my code clears up. All right, so that was a create statement for customer. Here are the insert statements. Don't forget to put your attribute names and the insert statements. Don't forget, after each one of these records, I use a comma, not a semicolon, until the very end. Notice these are all commas here at the end, except for the last one, which is a semicolon. Show warnings, and we're off to the next table structure. Notice also I do a select all just to make sure. I have it in comments here, but if I wanted to test that out to make sure there's data in the customer table, I do my select all there. I could also do it at the very end after all my tables are created, all 4 tables. There's going to be 4 tables: dealership, sales rep, customer, and vehicle. I could do them after each one is populated, or at the very end after creating and populating each one. I can put all select statements there. All right, here's essentially the super table, the parent table of all the tables is dealership, and we could show that. Here's the create table for this, and then show warnings, and you could take a look at that. Notice that I'm doing for the zip code and phone number. I'm sorry for let's see. I don't think I went over that here. Yeah, so for Social Security number, I think I probably said this in class, but for Social Security number, there are some Social Security numbers that can be zero filled. Okay, and that's why we do the zero filled. There are no phone numbers that can be zero filled, as I have in the comments right here. Okay, but zip codes can be zero filled, and that's the only reason I'm using that is just to show you how to use the zero fill option. So zero fill for our Social Security numbers, and zero fill for our zip codes. Just as an FYI, you probably won't see any Social Security numbers zero filled because they came out. Social Security numbers, I believe, was 1935 or 36, somewhere around there, 35, 36. And there were some zero filled zip code. Social Security numbers at the time. But I think those have been all used up since. Okay, so going back to that's the population, or populating the customer table. I already paused that. Let's do the dealership and pause that. So here's my dealership create statement. Notice the index there, using index on dealer name, because someone might call up and ask for a dealer name, and so you want to make sure you index your attributes that will be searched or sorted a lot, and that'll make it for faster data retrieval. Index the attributes that will be searched or sorted often in your SQL statements. Here are the inserts for that. So insert in the dealer. Now you don't have to have these records. What I suggest you do, you could put your own data in, but what I suggest you do is, perhaps to get it working, use the data that I'm providing here for you. That way, if you get any errors and you're using my data, it's you missed a semicolon or a single quotation mark or something like this, because this data will work, and I'll show you that it'll work. Okay? But use my data first, and then you could go back and put whatever data you want in there. Notice the select all from dealership to make sure it's populated. It is commented out right now. It is commented out. Can I get this all in one fell swoop? I think I can. Yes. So here's everything for sales rep. And then don't forget your show warnings as well. So that's everything for sales rep. So we did customer, we did dealership, we did sales rep. No Social Security number is zero filled. Notice the zip code is zero filled. There's how to use comments as well. I put comments in there so you know how to use comments. Notice the explicit definition for the sales rep ID as a primary key there. Notice that every primary key is automatically, not automatically, but notice that every primary key is auto increment. And when you spell auto increment, there's an underscore, auto underscore increment. So make sure you spell that correctly, otherwise you will get an error. All right, gang, that's the definition for the sales rep table. Here are the data for the sales rep table. Again, I highly suggest you use my data just to make sure it works, and then after that, put whatever data you want in there, and that way if you get any errors, you can fix that because the errors are from your data. Okay, next is the vehicle table. Now, the vehicle table actually has two foreign keys, dealer ID as well as, I should say, dealer ID as well as customer ID. So we're going to, I don't think, yes, I guess we can. So here's everything from the vehicle table, all in one screen. Notice the two foreign keys. We're indexing both foreign keys. We're indexing, and we could also do an index on VIN number, by the way, too. We could index VIN number. Now, I put a comment there for VIN number. The only primary key that's not auto increment is for vehicle, and I put a comment in there. So vehicles made after 1980, they all have a 17 character, at least made in the United States. Made in the United States, and Canada, by the way, and Mexico. Let's just say North America. They all have a 17 alphanumeric value. So all vehicles made after, and you could research that if you want as well too, but all vehicles made after 1980. Before 1980, each of the auto manufacturers had their own method of doing VIN numbers, that's vehicle identification numbers. But since 1980, I should say after, in other words, 1981, or even if there was a 1980 and a half vehicle produced, it would have a 17 alphanumeric character value for a VIN number. Two indexes, dealer ID, customer ID, two foreign keys, one for the dealer ID and the other foreign key is a customer ID. And then finally, we're going to explicitly give an engine to all the tables, NODB, default character set. And by the way, you can give different engines to different tables if you want, just so that you know that. That's why I explicitly define these engines, character sets, and collations. Here's the data. Here's some data for vehicle. Show warnings. And then don't forget to turn foreign key checking back on. Okay? Turn foreign key checking back on. Alright, gang. Now, I'm going to stop here with this video, other than I'm going to show you how to pull this in, and you could do the same thing both for locally and remotely. I do want to caution you, though, using these T commands. I'll talk more about the T commands when in our next video. So don't worry about these commands for now. Realize, though, that I am using a T command here. The others are commented out. So these are commented out. This is how you would do it on the CCI server. But, yeah, you wouldn't use my username, you would use your username. So all of these would reflect your user ID. Okay, turn foreign key checking back on. And then what I'm going to do is I'm going to create this report here. Okay, A3 reports. Use the T command. At the very bottom, you see that I put no T. My very last command is no T. So everything here, all of these exercises that we'll be doing in the next video, will all go to a file. The file's name is this. Oh, I'm sorry, I deleted it. You'll see it here in a second. This is my A3 solutions file. The file name is actually this. Right here. This will be the file name. When I run this, you'll see that the file is created. So I'm going to pull this off to the side. Now what you're going to see, gang, is not only my tables created, all of these tables created, all of these tables, the four tables, dealership, sales rep, customer, vehicle, with data, but you also see that the answers for the exercises, which I'll go over in another video, will also be displayed. Okay, so I'm going to pull this off to the side. I want you to watch something here. I'm going to run this command. See that this is just a backup file for that MySQL. I'm sorry, that Emacs does for me automatically. I'm going to put this over here so you can see the file being created. Okay, I modified this. I did a change here. What was the change? Oh yeah, I want to put Billingsgate back. So I want to put that apostrophe right here. Okay, so that was in the customer table, and notice here, just so you can see. Notice I'm using that apostrophe. I want you to know how to do an apostrophe in SQL. You have to escape it using the backslash character like that. Okay, because this is treated as a apostrophe, because this entire address is treated as a string. Notice that the beginning single quotation mark and the ending single quotation mark for address, or I should say street, right? Cus_street. But it happens to have an apostrophe in the name of the street, which is Billings. So I have to put that backslash character in there. All right, enough of that. I'm going to save this file, and what I'm going to do is I'm going to pull this off to the side, and I'm going to run this command here. What I'm going to do is pull up my command prompt. Okay, I'm going to, again, Windows using command prompt, Mac users using terminal. I'm going to log in here locally. Now you don't do this, you're not changing your port, but if you want, you could actually run it like this, 3306. You could do that, or if you wanted to, you could the better. I'm using I really shouldn't have showed you a bad example there. Really, it's a variable. It's an option essentially, but it's a variable that I have this global variable that I use in my initialization file, and I actually changed the port name. Your port would be, this will work for you, but you don't have to put it, because if you don't change the port, it'll automatically look for 3306. That's MySQL's default port that it looks for. However, I changed the initialization file to mine to 3308. If you change it to anything other than 3306, you must explicitly define that when you're trying to log into MySQL. Okay, so I got that, my password, and I'm in. I'm going to use mjouet, and then I'm going to drop the database. Drop database. I know it's in the code. I know it is. It's up here in the code. So I'm being redundant here, right? It's actually, it would drop this anyway if I just pulled in the file. So what I'm going to do is I'm not going to do the job database. I'm going to do show tables. Okay, so those are my tables right there. Now, because I'm pulling in this file right here, it's going to drop the database, create the database, and start using my database and creating all these tables, including those exercises. So watch me do this. Fast way, gang. Mac users, it's even faster. You could actually pull the file in, and it'll find the file and the command. You know what? I forget if this works on a PC. I know it works in a Mac. Let me try this. I'm going to try to pull in this file here, like this. Yeah, okay, it does the same thing. So I forgot about that. I have done this before, and I forgot all about that. All you have to do is wherever you have that file on a PC, just drag it to your command line, and it will automatically pull in that path. Mac users, it does the same thing in terminal. However, I forgot one thing, and that is this. Got to use my source command, right? So I could explicitly type it like that. Or I could do this, /dot, And I always use \dot, so I'm going to do source command. But make sure you have a space after that. And then watch what happens. I'm going to hit this. I'm going to pull this off to the side. And then I want you to see the report file. It's going to be right here in this white space. Watch it be created. So notice it's coming to standard output, all of those exercises. And I'd actually put it over here. Let's see, where is it? Might have to do a refresh here. And where's my file? It's showing that it's, hold on, I may have put it to the wrong, let's see, what do I have here for a drive? That's the problem. I'm glad this happened. I got to go back in here and change my drive. Let's do that. Right here, use a T command. Notice I have the F drive. That's incorrect. So I have to put the D drive. And everything else should be there. Is that the correct path? Courses and _LIS. Yeah, I have the underscore there. My courses. And yes. Okay, so instead of F, it's in my D drive this time, so I'm going to change that. And notice these are just comments, so that's not going to work. And I am going to save it. I'm going to run this again. So run this again, go back to here. Let me, well, I'll just run this as, no, let me exit out of here. Let me clear this. Let me log in again, just so it's not all busy. And let me just run that command, just like this, without even using my database. I'm just going to run this command. Notice the warning there. See the warnings? And it even shows my routine. You'll see that as one of the exercises, output disabled. Now, look at my reports file right here. Oops. I'm opening up this reports file, and it's showing everything that you need that will go into, let me put this in a larger font and different color, and you can see all the reports. And we'll go into that into another, this, by the way, this error is on purpose, and you'll see why that error was generated. But we'll go through the exercises in another video. All right, gang. See you in a bit.